All right, so right before lunch, we ended up talking about this thing called a corollary, which is another word for just, oh yeah, while we're at it, I want to talk about one more thing. So we have postulates and theorems and corollaries. A corollary is just a related topic. It's kind of not strong enough to stand on its own as far as an idea. But, oh yeah, while we're here, let's go ahead and talk about this. So with this corollary, the triangle sum theorem says is the acute angles of a right triangle are going to be complementary. Now, that totally makes sense to you. Because if I know that the sum of the angles in a triangle are 180 degrees, and one of those angles is a 90-degree angle, then you know that the other two have to add up to be 90 degrees. Does that make sense to you? Yeah. So it's kind of like, you know, kids always like, so tell me again what a corollary is. It's one of those, oh yeah, while we're at it, I'm going to explain one more tiny little detail and see if this makes sense to you. It's related, not enough, oops, not enough to necessarily stand on its own, but an idea that's definitely worth mentioning. Corollary to the triangle sum theorem. Okay. So on your little pizza tabletop is continuing on for our exterior angle theorem. And we kind of already talked about the exterior angle theorem when we talked about that warm-up that we did. So when you had your homework and we talked about this idea here, and then I said that we were going to talk about angles 4 and 7. Angles 4 and 7 are exterior angles because they're outside of the triangle. We can see that. 2 and 5 and 6 are inside. 4 is outside. 7 is outside. But 1 and 3 are not exterior angles. And by definition, an exterior angle is going to be when you extend one of the sides of the triangles and create an angle. So if you look at 1 and 3, if I extend those sides of the triangles, extending here creates this angle and this angle, but neither of those two. Extending this side of the triangle does not create angles 1 or 3. Extending this side of the triangle creates angle 4. Extending this side of the triangle creates angle 7. Because 4 and 5 are supplementary, because 5 plus 2 plus 6 are supplementary, I know that there's that cool relationship where 4 has got to have the same degree measurement as the sum of 2 and 6. And that basically is what our exterior angle theorem says. It says the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent or remote interior angles. So when we talk about extending this side here, I understand that angle 1 is my exterior angle. So write yourself a little note. Angle 1 is an exterior angle. And he is going to have the same measure as angles 2 and 3 put together. And that is because angles 1 is supplementary with this angle, and 2 and 3 add together to this angle measurement to equal 180. So we understand that then those have to be the same. So the measure of an exterior angle is equal to the sum of the two remote interior angles. So kids have a hard time with exterior angles, so you have some here. And what I want you to do is I want you to extend a triangle side, and I want you to mark angle 1 as an exterior angle if these are your two remote interior angles. So you're not going to extend this side because that doesn't make the remote interior. So I want you and your partners to play with which sides you can extend so that 2 and 3 are the two non-adjacent or remote interior angles. With your partners, talk about it. Go. All right, so when I go to extend my side, the interesting thing here is I can extend this side here and create angle 1. So let's talk about what I know. I know that angle 1 is supplementary with this angle here. And I know that this angle plus these two equal 180 degrees. So then I know that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So question, did anybody extend this side? Yeah. Let me ask you something. Do you think those two angles have the same measure? Yeah. Because why? Who said it? Because they're vertical angles. Ariane was about to explain another reason, and that's, well, because they're going to have the same measure because they're both going to add to 2 and 3 to equal 180 degrees. Yeah. So there's two justifications. Those two angle ones are vertical angles. They have the same measure. And you can extend that side, either side, in order to create. All right, let's talk about this one. Raise your hand if you extended this side. All right, raise your hand if you extended this side. Guess what? They are both exterior angles and have the same measure as the sum of these two remote interior angles. All right, raise your hand if you extended this side. Raise your hand if you extended this side. Okay. They are both remote interior, they're both exterior angles and have the same measure as the sum of 2 and 3. All right, here comes, I bet you everybody did this one. Anybody do this one? Yeah, this one was a harder one. All right, so our exterior angle theorem says the measure of this exterior angle is equal to the sum of these two. All right, I want you to think about right now, how would you construct a proof? Or, better yet, let's say I forgot the exterior angle theorem and I needed to find the measure of that angle. You would work your way back through these being supplementary and these adding up to 180 degrees. So your brain needs to be spinning around those different ways that would work out for you. All right, theorem 4.3 talks about our isosceles triangle theorem and the converse. Are you ready? If two sides of a triangle are congruent, then the angles opposite them are congruent. If I have two sides of an angle that are congruent, if the sides are congruent, and we're going to start with those sides being congruent, then the angles opposite them. So this angle is opposite this side, and this angle is opposite this side. If the sides are congruent, then the angles are congruent. Now I have the converse, where I have, if the two angles of the triangle are congruent, if I have these angles congruent, then I know that those sides opposite them are also going to be congruent. We're going to come back and prove these in a few weeks. So remember the idea of what a corollary is? Oh yeah, while we're at it, This is related, a little bit different, but kind of the same. If a triangle is equilateral, then it's equiangular. If a triangle is equiangular, then it's equilateral. If I have three congruent angles, then I'm guaranteed to have three congruent sides. So that equilateral conversation is important there. All right, let's talk about some more concepts about isosceles triangles. So when we're talking about isosceles triangles, our congruent sides are going to be the legs, and the third side is the base. Do me a favor, please, and draw an isosceles triangle that's tipped over, opposite from what you usually see, and make sure that you understand that it doesn't matter where the base or the legs are. The two sides that are congruent are the legs, and that third side is the base. So this one's easy to see where I have the base, and kids think that that's because this is on the bottom, and it has more to do with the fact that it's not one of the congruent legs. So the two sides that are congruent, those are the legs, and then that bottom is the base. Our congruent angles are going to be our base angles. So these two opposite congruent angles are opposite of my legs, and those are what we call the base angles. And the angle that's opposite my base is going to be my vertex angle. And here's the all equilateral triangles are also isosceles. The crazy thing about an equilateral triangle is you can spin it any way and talk about legs and base. There's no one base. All right. Right triangles. You have a right angle, and the side opposite the right angle is always going to be the hypotenuse. In a right triangle, the right angle is the biggest one. So the hypotenuse is always going to be the longest side. Your hypotenuse is opposite your right angle. And when we talk about opposite, we talk about across the triangle. The other two legs of a right triangle are going to be, we can have a long leg and a short leg, or if it's isosceles, both of those legs can be congruent. And I know that those are congruent because I have 45-degree angles. Here is my right angle with a measure of 90 degrees. Here is my hypotenuse. This is my leg. Sound okay? All right, so we've got some practice for you. Classify the triangles by angle and side. Solve for x. And then solve for each unknown variable. On your mark, set, think. All right, let's talk. So let's talk. For number one, these two marks show me it's isosceles, which means these two have to have the same measure. These two have to be supplementary because they're a linear pair. So if this is 50, so is this. So that gives me 100 degrees. The inside measures of a triangle are 180 degrees. So that's got to be 80 degrees. When I look at that triangle, that makes it an acute because they're all less than 90 degrees. isosceles because I have two congruent sides. You okay with that? Okay. Take a look at the second triangle. I know that these two angles are congruent. So these base angles mean that these two sides have to be congruent. So 4x minus 4 is equal to 24. I get x has a value of 7. So each of those sides is 24, but nobody gave me any angle measurements, so I can't classify that by angles yet. We're going to do it in a little bit, but not yet. All right. Solve for each unknown variable. X and 70 are a linear pair, so x has to be 110. You okay with that? Once I get x is 110, 110 plus 30 is 140, which means that top skinny angle has to be 40 degrees, which means that y has to be 140. Are we okay with that? I'm going to call that an obtuse scalene triangle. Would you agree with that? Because x is greater than 90 degrees, I'm going to call that obtuse scalene. So you're all being very rude right now because I'm still talking and going over, and you're chatting, you're packing up, you're clicking, and it's rude. It's not how you behave. Not when a teacher's talking. This last one, here I have a 90, which makes this 30. Then I get my 90 and 60 from vertical angles. Hey, make sure you throw out your little green triangles on your way out. Please don't leave the trash.